about rational exponents. What's a rational function? When we graphed them, oh, it was joyful. There were vertical asymptotes, horizontal asymptotes, oblique asymptotes. It was so much fun. But what is a rational function? How did we describe it, Anne? Very good. Yes, it had a numerator and a denominator. By definition, it was a polynomial in the numerator and a polynomial in the denominator. It was a fraction. So if we're dealing with rational exponents, we're going to deal with fractional exponents. Hey. And it looks like this. By definition stated, if the nth root of a is a real number, okay, that's super important, m, which is the numerator, is an integer, and m over n is in lowest terms. Whew, it's a lot to think about. We have the following. Here we go. Write this down with me, please. The nth root of a is a real number. Okay, so we're going to say that the nth root of a is a real number. We know that m is an integer and m over n is in lowest terms. Then we can say that a raised to the m over n power. So a raised to this rational exponent can be rewritten. We can rewrite it as the nth root of a to the m. We can also write it as the nth root of a raised to the m power. They are all equivalent. So what's the important part for us to remember? That the denominator is our index, always. And the numerator is the exponent. Okay, the denominator is the index, and the numerator is the exponent. Now, before we get into playing with this and switching back and forth between the two forms, let's review our properties of exponents. If we have the product property, so if I have the same bases being multiplied, what do we do with their exponents? How do we combine the two terms? We add them, right? Okay. What if we were dividing the same bases? Then what do we do with their exponents? We subtract them. And it was super important to note that it's always the numerator being subtracted by the denominator for the exponent. What if I had a power raised to a power? What did we do? We multiplied the two powers together. Excellent. What if we had a quantity, so a product, being raised to the same exponent? What could we do with that exponent? Yeah, just distribute it inside of the quantity. Every term inside of that parenthesis was raised to the power. This one was always a little bit tricky for students, and still is in my pre-calc class at times. If we have a raised to a negative power, what does that do? Haha, very good. We take the reciprocal of the base. And I'm going to say that a lot, because now that we're dealing with rational exponents, if we have 9 raised to the negative 1/2 power, I don't take the reciprocal of the exponent. Okay, you're taking the reciprocal of the base and then simplifying from there. You might want to write that down if you think you're going to forget it, because it is really, really important. And I'll write it down here so that we can see it. You only take the reciprocal of the base when applying the negative exponent property. And the base is whatever number is being raised to the exponent. Take the reciprocal of the base only. Pardon me. So even even though now we have fractions in our exponents, the properties are the same. It's not going to change because we're still dealing with exponents. The only thing that we have to watch out for now is that fractions do have some very specific rules. In order to add or subtract fractions, what do we need? Allie? Ooh, for radicals, yes. Nice job, by the way. But for fractions, what do we need in order to add or subtract fractions? Oh man, that common denominator. So when we're dealing with rational exponents, we have to remember the exponential properties, but we also have to remember that fractions have their own rules as well. So notice we're going to add their exponents. We're going to raise a power to a power. All of these properties are still the same. The only difference is now we have one more thing to think about with the fractions. What is any base raised to the 0 power? Huh? 1. Yes. It's not 0, as much as we'd like to say that. I did have a student years and years ago who used to tell me it was 72, and he thought he was so funny. Matt Akita, if you know him or you know his family, give him a hard time. I think he did it just to drive me nuts. But no, anything to the 0 power is 1, which is nice to fall back on that. All right, here we go, everyone. Let's get to it. Remember, denominator is the index, numerator is the exponent. What is the simplified form? Well, 625 to the 1/4 power looks a little strange to me. But I know that we can rewrite it into radical form. Let's do that. That gives us the 4th root, because 4 is my denominator, of 625 to the 1st power. Denominator is the index, numerator is the exponent, and from our definition box at the very beginning, we know that we could also write it as the 4th root of 625 quantity raised to the 1st power. In this particular instance, it doesn't matter which one we choose because anything to the 1st power is what? Itself, yeah. So that's not going to make a difference. What is the 4th root of 625? 5. Very good. Nice job. So we can simplify this down to 5. And we are done. Denominator is the index. Numerator is the exponent. All right, if we look at example B, we're multiplying exponential terms, right? There's a base and an exponent. Do they have the same base? No. The first term has a base of 12, and the second term has a base of 8. They are not identical, so we cannot add their exponents. But, well, in the past, we would say, no solution, this is as simplified as we can go. But now we know that we can rewrite these. So if you cannot simplify as given with your rational exponents, rewrite them. And see if that allows you to simplify once you've rewritten them. For 12, our index is 3, so we're going to take the cube root of 12, and we're going to multiply it by the cube root of 8. Well, shoot, we know what the cube root of 8 is, right? What is it? Yeah, good. So we can simplify this to be 2 times the cube root of 12. And what are the factors of 12? What multiplies to 12? 4 and 3. Perfect. All right. And then if we break down the 4, we get 2 and 2. Do we see any groups of 3? No, we don't. So this is our final answer. But our question was phrased with rational exponents. So we should put it back into that form as 2 times 12 to the 1/3 power. Now, realistically, if you leave it as 2 times the cube root, I am not going to take points off because you understand the problem. But it's just a nice little challenge for us to go back to the original format. You could also put the 12 to the 1/3 in parentheses if you would like. Any questions on A or B? What's the denominator again? Index. Well done, well done. All right, let's move on to example number 9. Get it on the screen. There we go. So the question for us is, how can this notation help us simplify radicals by reducing the index? I can't talk. Again, which of these can be simplified? Well, if we look at the 4th root of 9, immediately I'm thinking I can't simplify that. But now, thanks to skill 5, I have a little bit more of a resource in manipulating the given. I can, with your help, rewrite this, maybe, oh my gosh, come on, as 9 to the 1/4 power. Would you agree? Yeah, okay. But 9 can be manipulated also. How could we write 9 so that it is in a prime form with an exponent? 3 squared. Okay, let's do it. Morning. So we have 3 squared to the 1/4 power. Why are we doing this? To try to simplify. Now, it might not lead us anywhere, or it might. We'll see. What do we do if there's a power raised to a power? What do we do with our exponents? We multiply. Perfect. So this then becomes 3 to the 2/4 power. Can that reduce? Yes. So then we have 3 to the 1/2 power. Ooh, what's my index now? 2. Excellent. So the 4th root of 9 can reduce to the square root of 3. All by rewriting into rational exponent form and then playing around a little bit with the base and how we can rewrite the base. Let's look at B and see if that can simplify. The 4th root of 15. Okay, well, I'm going to rewrite this. What's my index again? Is that the numerator or the denominator? Denominator. So what would be our numerator here? 1. Excellent, because it has an exponent of 1. So 15 to the 1/4 power. Okay, can we rewrite 15 at all? No. So can we do anything? No. Bummer. This is simplified form. But we do need to write it with a rational exponent just to see if maybe we could manipulate a little bit. But in this case, we couldn't. Let's take a look at one more. And then if there are any questions out there, of course, I will take them. The cube root of 25. In fact, try that on your own. Well, right away I'm thinking there's a possibility because I know that I can rewrite 25. How can we rewrite 25? 5 squared. So if we rewrite this as 25 to the 1/3 power, and then we rewrite 25, I'll write it again, 25 as 5 squared to the 1/3 power. What do I do when there's a power raised to a power again? Oh, we multiply. Thank you. So we get 5 to the 2/3 power. Can that reduce at all? No. So is there anything we can simplify? No. Because if we were to put this back into radical form, we get the cube root of 5 squared, which is exactly what we started with. So for these 3 examples, there's only one that we were able to manipulate, and that was A. And what's the common theme? What did I mention about C? What if the radicand is a something, we could rewrite it. Could we rewrite 15? Unfortunately, no, right? But 9 and 25, what are they? Perfect squares. So that's something that we want to watch out for. If you have a radicand that's a perfect square, or even maybe we had a radicand of 8, we could rewrite that as 2 to the 3rd power. Or maybe we had a radicand that was 64. We could write that as 4 to the 3rd. Or 2 raised to a different exponent. Really pay attention to those characteristics for your radicands when you're looking to simplify and rewrite. Any questions on example number 9? Okay, let's move on to example number 10. It's asking us to rewrite the expressions in radical form. Things we need to watch out for. Example number A sub 1. What is the exponent attached to? Allie? The y, not the full product, right? It's not attached to the -2. It's just attached to the y. So we would write this as -2 times y to the 4/5 power. And the reason I like to split it as such is to give me a visual reminder that that exponent is only on the y. Now let's put it into radical form. What's the index for the radical? 5. What's the exponent? Yeah. So this is the 5th root of y to the 4th. Can we simplify the radical at all? No, because we only have 4 y's and we would need at least 5 of them. So that's our final answer. Okay, let's take a look at the second. Pardon me. Oh, I see a negative in my exponent. What is that going to force us to do? The reciprocal of the what, Christian? Yes! Very good, sir. We're going to rewrite this as 1 over d to the 3/2 power. Do not take the reciprocal of the exponent. I can't stress that enough. That is not a part of the property. All right, what's the index, everyone? 2, thank you. So that means our exponent must be 3. So we have the square root of d cubed. Now the directions asked us for radical form. Boom, we're in radical form, but can we simplify? Yes. How many groups of 2 can you take out of 3? Just 1, all right. So then this is going to leave us with 1 over d times the square root of d. Do I need absolute value bars? Anne didn't even hesitate. Why not? Excellent. Yes, because our d, that's the radicand, has an odd exponent. So we don't need to worry about absolute value bars. Can we rationalize here? Sure we can. Christian, what should we multiply to the numerator and the denominator? Radical d. Nice job. Our index is 2. We only have 1 d, so we need to have 2 total. This is going to give us the square root of d over d times the square root of d squared. It's a lot of d's. What is the square root of d squared? Yes. So we get the square root of d over d times d, which leaves us with the square root of d all over d squared. It's a very terrible tongue twister. Any questions on 2? Okay. I would like, please, for you to try b on your own. Rewrite these 2 in exponential form. AB cubed. What did you write? Well, let's think about this, yeah? We're having the quantity of AB cubed raised to the 1/2 power. Would you agree to that? Okay, because the product, AB cubed, is just raised to the first. There's only one of those, and the index is 2. But if I have more than one term in the parentheses in the quantity, and it's raised to the same exponent, what do we do with that exponent? Ah ha ha! Yes, we distribute. So your final answer should be A to the 1/2, B to the 3/2. Excellent. Hands up if you have that on your paper, please. Nice. Great, nice job. What about number 2? Can somebody help us? What did you write for number 2? Yes, thank you. W raised to the 2/3 power, since 3 is our index. Nice. Really important that we're comfortable with writing from radical to exponent and exponent to radical form. Because in example number 11, it's a free-for-all. We're going to be asked to write each expression in simplest form. And we're going to have to remember that we can toggle back and forth between the two. So looking at A, we have the 6th root of 10 times the cube root of 10. Can I multiply those? In order to multiply radicals, what do we need? Jules? No, the same what? Index. Yes, we need the same index. Do they have the same index? No, definitely not. So normally, before today, we would say that's as far as we can go. But now we know that we can rewrite this. We can rewrite the first radical to be 10 to the 1/6 power times 10 to the 1/3 power. This is super helpful because with exponents, we know if we're multiplying the same bases, what can we do with their exponents? We can add them. So I'm going to rewrite this as 10 to the 1/6 plus 1/3 power. With this with this product property for exponents, we don't do anything with the bases. It works out that since the bases are the same, we can combine them into one term by adding their exponents. Okay, oftentimes we will forget and we'll try to multiply the bases, do something funky with it. Leave them alone. In order to add fractions, what do we need? Common denominators. What would their common denominator be here? 6. Lovely. So please multiply 1/3 by 2 over 2 with me. Remember that in order to get the common denominator, you must multiply the numerator and the denominator by that number. So we get 10 to the 1/6 plus 2/6, which gives us 10 to the 3/6 power. Can that reduce? Heck yeah. What is it, Hugh? 10 to the 1/2 power, which in radical form is what? What's my index? 2. Very good. So we get the square root of 10 as our final answer. Nice. Lot to think about. If we can't multiply the given, always rewrite to see if that helps us. In this case, it certainly did, but we had to get common denominators and then reduce. Hello, B. Can we reduce this as is? Allie says yes. Allie, what can we reduce it to? To outside? Ooh, it sounds good to me. I think you're on the right track. Let's write it out and see if she is right. Nice job doing that in your head, by the way. That was tricky. What multiplies to 64? Okay, wait. I heard 8 and 8, and then what did you say? 16 and 4. Sorry. Both are great suggestions. Yes. So we've got 8 and 8 is what I heard first. And then 8 breaks down to 4 and 2, and 4 and 2, and then 2 and 2, and 2 and 2. So here we have our prime factorization. A 2, a 2, a 2, a 2, a 2, a 2. And we need groups of what? We need groups of 4. So we've got 1, 2, 3, 4 2's. We can pull out one group of 2, and what's left underneath? Yeah, was Allie right? Sure was, nice job. But let's say that you're maybe not as comfortable with simplifying radicals as Allie just showed us she is. And you're like, man, I just really hate radicals. Like, this whole unit is giving me anxiety. Well, first, I am sorry. But second, now you have a little bit of an option. If you don't want to simplify the radical as given, rewrite it as 64 to the 1/4 power. Can we rewrite, 64 as a base to some exponent? 8 squared. Okay, let's do that. So 64 can be rewritten as 8 squared to the 1/4 power. Now, as we saw in a previous example, we can then multiply, because a power raised to a power says that we multiply the powers, and we get 8 to the 2/4 power, which we can reduce. It becomes 8 to the 1/2 power, which then is just the square root of 8. What is this? Nobody knows. 2 rad 2. Very good. Which form is more simplified? 2 rad 2. Oh, man. So now, Skill 5 has brought us more resources to simplify, right? It's also brought us a little bit of a challenge in the sense that when we simplify our radicals, we always need to check if we can simplify further. So if you're comfortable with simplifying the radical, as we saw with that first example, yes, please do so. But you must always check, oh man, can I still continue to simplify? Let's see if we could. We have a 2 on the outside, and then we have 4 to the 1/4 power. Can we rewrite 4 to be a base raised to an exponent? 2 squared. Excuse me. So we still have that 2 on the outside. Now we have 2 squared raised to the 1/4 power. We have a power raised to a power, multiply. So we get 2 times 2 to the 2/4. And what does 2/4 simplify to? 1/2. So we get 2 times 2 to the 1/2 power, which is 2 times the square root of 2. So 2 roads, 2 options. You could immediately rewrite into rational exponent form and then simplify. You could simplify the given radical, but remember, you must always ask yourself, can it simplify further? Can I rewrite the radicand with a base raised to an exponent and then simplify from there? Any questions on B? You might want to, on your notes, write down a little reminder too if you're forgetful, or if you just need that little reminder, to always check if you can rewrite the radicand as a base raised to a power to help you simplify further. All right, example C. Ooh, there's a negative. Do I get to take the reciprocal of the base? Oh, Christian, you're mean. Why are you shaking your head no? Yes, very good. If the base is negative, that is not an exponential property. Okay, the only time that we're going to apply the negative exponent property is when the exponent is negative. Oh, sad day for me. All right, so negative 64 raised to the 5/3 power. Let's rewrite this, everyone. What is our index? 3. Lovely. Thank you so much. So we're going to say that it is the cube root of negative 64 to the 5th power. But remember at the beginning when I wrote it in two separate ways, you could have the exponent under the radical, or you could have the exponent out of the radical. The neat thing about having these options is that they do give you the same answer, and they give you some freedom to make a choice based off of your comfort level. What do you think would be easier for you? So looking at these two options, what do we think would be easier? Do we want to raise negative 64 to the 5th power and then take the cube root of that? Or do we want to take the cube root of negative 64 and then raise that to the 5th power? What should we do first? The exponent or the radical? Huh? Yeah. If, in my opinion, right, if we take the cube root of negative 64, what do we get? Negative 4. That's going to be a little bit easier to raise to the 5th power than if we were to take negative 64 and multiply it to itself 5 times, holy smokes, and then try to break that down with the cube root. So please make sure that you understand and that you know you can either apply the radical first or apply the exponent first. It'll work and give you the same answer. So let's not apply the exponent first. We know that the cube root of negative 64 is negative 4. And feel free to take out your calculators. What is negative 4 to the 5th power, please? Yeah. 1024 for negative. Oh my gosh. Thank you so much. Yes, negative 1024. Did you use a calculator? No? Did you do it in your head? Yeah. Very impressed. That is very exciting. Thank you so much. Negative 1024. Any questions? Alrighty, everyone. We've got a few more. Be excited. Here we go. 32 to the negative what? Do we have a decimal property? Yeah, not that I know of. Shoot. Okay, so we've got negative 1.2. Couldn't we write that in a fraction? Because we're dealing with rational exponents. So let's try to get it into a format that we are used to dealing with today. Negative 1.2. That can be written as negative 1 to the what? Or times what? 0.2 can be rewritten how? Allie? You're good. So it's 2 over 10, which then reduces, as she said, to 1/5. Excellent. But we're not dealing with mixed numbers. We're just dealing with either proper or improper fractions, right? So how could we change negative 1 and 1/5 to be an improper fraction? Nathan? Excellent. Yes, this becomes negative 6 over 5. So if we're presented with a decimal exponent, let's change that into a fraction. So this becomes 32 to the negative 6 over 5 power. What do you see? What's on the exponent? Negative. So let's take the reciprocal of the base. not the exponent, okay? So here we go. We have 1 over 32 to the 6/5 power. What's our index? Okay, good. 5, and Gabby, I saw that. Thank you. So we have options, everyone. We could write this as 1 over the 5th root of 32 to the 6th power, or 1 over the 5th root of 32 with that answer raised to the 6th power. Do we want the first option or the second? Jimmy, I agree. Let's do the second. What is the 5th root of 32, everyone? 2. Nicely done. So we get 1 over 2 to the 6th, and then what is 2 to the 6th? Nice, very nice. So we get 1 over 64. Nice. You're getting a lot of variety today. It should be very helpful when you get to try your homework. Any questions so far that you haven't asked yet? All right, I believe we do have a couple more. Let's take a look, and then I'll pass out your exams, and you'll have time to work on your reflection packets and your Skill 5 homework. For E, we have 9y square root of x raised to the 3/2 power. Okay, if we have numerous terms inside of a quantity, and there's an exponent on the outside, you have told me a few times today that that is going to distribute inside, yes? Okay. Well, the x isn't a radical. My exponent is a rational exponent. I would like to have it all in the same format. So I'm going to rewrite the square root of x with a rational exponent. What is that? X to the what power? 1/2. Good. And then it's raised to the 3/2 power. Okay. So in distributing the 3/2 inside, we end up with 9 to the 3/2 power times y to the 3/2 power times x to the 3/4 power. When you multiply fractions, you multiply numerator to numerator, denominator to denominator. All right, I'm going to go ahead pardon me, and simplify the constant. 9 to the 3/2. Goodness, my apologies. That is the square root of 9 cubed, or the square root of 9 cubed. Which one would we prefer? The first or the second? Second, Jimmy? All right, let's go with it. So the square root of 9 is 3. And if we cube 3, what do we get? 27. Good. I'm going to put this in a little thought bubble to show that that was a little bit of a sidebar. All right, so we end up with 27 times y to the 3/2 x to the 3/4. All right, now, in order for me to be able to simplify the y and the x, oh man, it'd be really nice if we could put them underneath the same radical, because then we could pull out x's and y's maybe, fingers crossed. But in order for them to be under the same radical, they have to have the same what? Index. And where does the index come from? Denominator. Do they have the same index right now? But could we manipulate it so that they do? Yes. What could we multiply to 3/2 so that it has a denominator of 4? Yeah, 2 over 2. Just like we did when we were getting common denominators for adding the fractions. When you have a problem like this, you want to try to keep the indexes the same, so that we can put them underneath the same radical and try to simplify from there. So we find ourselves with 27 times x to the 6 over 4 power times y to the 3 over 4 power. Now they have the same index. The 27 stays on the outside, but we can write the fourth root of x to the 6th, y to the 3rd. We are able to simplify them. What did I do? I switched the x and the y, didn't I? Yep, thank you so much. As soon as I saw your hands, I knew it. Habit of wanting to write x first. Thank you for drawing that to my attention. All right, let's go ahead and see if we can simplify here. How many groups of 4 can I take from 6 y's? Yeah, just one. How many groups of 4 can we take from 3 x's? 0. 4x. So then we're left with the fourth root of y to the 2nd. Nicely done. X to the 3rd. Anything else we can simplify here? Allie? I think I see where you're going. Hang on, let's see if Aaron's seeing the same thing. Aaron? Ooh, do we need absolute value bars? That's an interesting thought. Bless you. What is y at the very beginning? What's the exponent on y at the very beginning? It's a 3. Very beginning. So, remember, just like we talked about with skill 3 with multiplying the radicals, always go back to the given. Aaron, great suggestion. Do we need them? We don't, simply because at the beginning y had an odd exponent, but so nice bringing us back to that. Thank you. Allie, are you talking about rewriting? Well, I think this is what you were saying. So if we have 27y, and then rewrite this as y to the 2/4, x to the 3/4, and then reduce from there? No? Okay. Never mind. Anything else we see, or have we simplified as far as we can go? Allie?
So I think it's 1 over the, like the radical symbol.
Uh-huh.
Yeah, because 1 squared over, the index, which is 4, simplified to y just over the index, which is 2.
Okay, so I think what we were saying was similar. You could, okay, so this gets tricky because it gets down, and thank you, it gets down to the question, how far do I go? When do I stop? If you stopped right here and said this was your final answer, I would accept that. If you chose to take 27y on the outside and then write y to the 2/4, y to the 3/4, so that you could then reduce, reduce to be y to the 1/2, y to the 3/4. I would accept that also. I don't know that it's necessary though. We do have to get into the habit of rewriting our radicals just to make sure we can't change the base, such as 4, 25, 9, 64, and so forth. But in this instance, I don't know that I would stress going any further. Great suggestion. Would I accept it as correct? Absolutely. So Allie, thanks for bringing that up. But I would think that this is fine also if they're under the same radical. Everybody okay with that? Yeah, Shiloh?
Is the third y supposed to be x?
Oh my golly. I mean, I guess so. Thank you. You've learned something about your math teacher. She has to have everything in alphabetical order, apparently. All right, let's do one more, everybody. One more. Uh-oh. What do we see on the exponent? Negative. So right away, if you have a negative exponent, everyone, make it positive. Apply that negative exponent property so you don't have to worry about it anymore. So we get 1 over the quantity of 27, x to the 6th, y to the 9th, raised to the 1/3 power. Okay, apply that negative exponent property so that you can then move on and not have to think about it again. Let's distribute. We get 1 over 27 to the 1/3 power, x to the 6/3 power, and y to the 9/3 power. Now, 27 to the 1/3 power is what in radical form? Excellent. The denominator is the index, so it's the cube root of 27. What does this simplify to? Good. So we have 1 over, the cube root of 27 is 3. What is 6 over 3 reduced to? X squared. And then what about y? Y cubed. Is there anything else that we can simplify here? Chloe, what do you think? No. Good guess. Believe in yourself. Have faith. This is our final answer. Woohoo! Any last minute questions, everyone? Last minute questions on rational exponents. Caitlin? Absolutely. So the question is, for f, could we have just put all of the terms underneath the cube root and then simplified from there? 100% yes. Thank you for asking. Oh.